Hello everyone, my name is Yanran from the University of Queensland, and today I'm going to share our work about CaseLink, the inductive graph learning for legal case retrieval, which is done by me, Dr. Ruihong, Professor Hongzhi, Professor Xue, and Professor Huang. And firstly, I want to give a very quick introduction of how the judges will make a judgment during the whole process. And firstly, given an unjudged case, the judges will often tend to find out the key legal factors of the cases, since the cases is often too long to directly read or comprehend. And then with the extracted legal factors, the judges will do the law matching and precedent searching. Firstly, for the law matching, the president will find out or locate the relevant law to these cases or to the legal factors. And another one is to find out the precedents, which refers to the relevant cases that to this case. And after they find out the law and precedents, the judges will do the reasoning part to combine the law and precedents and the facts of this case, and then to give the final judgment for this case. And during the whole process, the precedent searching is the most time-consuming task, since there is always a huge number of documents, legal cases. The judges need to go through them and find the most relevant cases. So, to tackle this problem, the legal case retrieval task is proposed to help the judges do the things. And here is a simple workflow of legal case retrieval. We want a retriever to find down the relevant cases to a query case within the large case pool. And here is a case examples in our data set. And since the legal documents or legal cases are all well formatted, so there are often 4 parts within the cases. The first part is the case name, which will include the parties of the cases, such as the plaintiff and defendant. And the second part is the summary part, which will summarize the whole long case within the few short sentences. But not every case will have the summary part. And the third part is the citation part, which is the most important part, or which is the label that will appear the reference cases in these cases of our data set. And the last part is the judgment part, which is the final decision for this case. And after we know the background of legal case retrieval, we find out some challenges that appears in this task. The first is the inductive nature of case reference in legal case retrieval. We can see from this graph that in figure A, here is the training set of our data set. And in this training set, we can link the cases by using the reference relation, which is the label in our data set. And in figure B, it is the test set in our data set. Since the reference relation or the label is our final aim to do or to predict in our method, so there is no more links in our test set. And also, the most important thing is that the test set is all the unseen cases. So if we want to do the legal case retrieval in the graph format, we need to do this inductive learning in our method. And another challenge is that the intrinsic case connectivity relationships are important for legal case retrieval. Here, we find out 3 important relationships that can help to uncover the relevance between the cases. And this as an example, we can see that if we use the label or the reference relationship, we can link the case with we can link the query case and the label case together. And another relationship is the semantic relationship, which we can link the two cases in a very high semantic similar situation. And the third one is the charge relationship, which refers to the charges that appear in this case, and we can link them together to indicate the relationships between this charge and the query case. So we use these three kinds of relationship to transform or convert pool of cases into a structured graph. And we will use these three kinds of edges. The first is the case-to-case edges, which is the blue edges, which indicates the semantic relationship between cases. And the second type of charges is the case-to-charge link, which is the link that utilizes the charge relationship, which refers to the charges that appear in a case, and we will link the case and this charge together. And final links is the charge-to-charge relationship. We will link two charges node together if these two charges have very high semantic similarity. And after we convert a case pool into a global case graph, we will go through and graph neural networks, and then to get the node representation as the case representation. And specifically, to train the CaseLink model, we use two kinds of learning method. The first is the congestive learning, and we will use the query node and the positive sample and negative sample, and then do the congestive learning by push away the negative samples and bring the positive samples closer. And for the graph structure learning, we will use degree regularization, which is called DAG-reg. The motivation of using the DAG-reg is, in real world, there is always a sparse situation, which means that the candidate case will be only related to a small number of query cases. And in our graph, it will reflect on the low degree of our graph. And the second motivation is to provide the training signal for candidate cases, since in the congestive learning, we will more focus on the query case and a small number of the negative cases. Then the huge number of candidate cases will lack of training signal, and we will use DAG-reg to providing the additional training signal for the candidate cases. And it is very simple. We're just minimizing the degree of the candidate nodes of our graph. And here is the experiment setting. For dataset, we use Collide 2022 and Collide 2023. That all comes from case law. For the baseline, we use BM25 BERT, law former, legal BERT, mono T5, Sailor, prom case, and case GNN. And for the matrix, we use 7 matrices that is often utilized to evaluate the legal case retrieval experiments. And here is the overall performance of our experiment. Firstly, we can see that CaseLink performs the best and even better than case GNN, which means that the intrinsic case connectivity relation can further improve the accuracy. And another observation is that the performance of the graph-based methods, such as the case GNN and CaseLink, are significantly better than the other text-based methods. And we also do the ablation study for this experiment. And the first observation is that when we add in the case-to-case edges, the performance will better since the effectiveness of case connectivity relationship works in our model. And another observation is that when we do the experiment without DAG-REG, the poor performance shows that the DAG-REG can effectively reduce the useless connections of candidates. And the final part is the case study part. We can see that here are two case pairs that the queries and ground truths are all far away or not close enough in the original node feature space. However, when we add in when we utilize the CaseLink model, the case-to-case edges can bring the case more closer by utilizing the intrinsic connectivity relationship. And also, in the second graph, we can see that even when case-to-case edges is failed, but the case-to-charge edges can also bring the case together by utilizing the implicit case and charge relationship. And as the conclusion, the global case graph can provide effective connections among cases. And also, the degree regularization can provide effective training signals for candidate cases. And the last one, and last but not least, maybe the most important thing, is that the structural legal information is very essential and important for legal case retrieval. And that's all. Thank you.